Today I'm going to show you how to control servos like these using the Embassy Rust framework. Embassy is a new platform for writing embedded projects in Rust. It has a couple of nice benefits, one of them being that you get to run tasks in parallel similar to an RTOS, but without having to deal with an extra operating system. It's just all in a single Rust binary. All right, let's get started with Cargo Embassy. We're going to start with Cargo Embassy init. We're going to start with the project name, YouTube Rest Servo, and then we'll do help. We can see what all the options are. Here we have chip, and the blue pill uses an STM32F103C8. Let's open that up. See, we've got a bunch of files in here now. Let's go ahead and give that a run to see if it works. And that's working. Great. Now, if you're used to regular Rust, you might be confused why cargo run is running on a device instead of on the local computer like normal. That is configured here in the cargo config.toml with the runner. We're using the probe-rs runner to run this. Let's go ahead and look at main to see what we're expecting it to do. We'll see that it's expecting that there is an LED plugged into pin B7, and it is going to toggle the LED on and off every half second and also print hello world to the terminal, which is what we see here. Let's control a servo. So servos are controlled with a specific width of an on pulse 50 times a second roughly. So in order to calculate how long we're going to be on, I'm going to add a little helper function here. Servo on time. We're going to give it the position of the servo, which is a number between 0 and 1. And we're going to output a duration. Duration is just like the one from the standard library, except that this time it's coming from the Embassy time crate. So here, the servo minimum is about 500 microseconds. The maximum time that we need to wait is about 2200 microseconds. And we're going to calculate how many microseconds we're going to be on by doing position multiplied by the total duration that we could be expected to wait for. We're going to add the servo minimum to it. And now we've just converted a number between 0 and 1 to a number between servo min and servo max. We'll return a duration from, these are in microseconds. And that was done. Now we know how long we need to wait. We do not have an LED. However, we do have a servo. In this case, we're connected to pin B4. We're going to want to start low. We'll change this to be servo. Now here, we're going to use our helper function. We'll start out by going to 0, and then we will wait. Now we could calculate how long we're going to wait low here. But a better option is, since we know that we need to send a signal every 50 times a second, Embassy has a nice helper called a ticker. Ticker, make sure we get that imported. We can do every duration from hertz. So we need this to do 50 hertz, 50 times a second. Now we can do in the beginning ticker, next, await. And this ensures that we will be sending a servo signal no more than 50 times a second. Let's see if this works. And it moved just a little bit. That's not very exciting though. So now we get to decide what we're going to do. Let's just move this to 1 just to see that that's working. All right, now we see that that's working. Now we've got this loop here, which is kind of a little bit frustrating to use when we want to use it multiple times. For example, if we wanted to alternate between 2 different positions, we could copy this code and go to 0. The problem is that the 20 milliseconds that it's going to be waiting is not long enough for the servo to actually reach the final position. So this time we're just kind of telling the servo to go to 1 and 0 about as fast as we can, and the servo cannot keep up. So we need to wait a little while. A simple way of doing that is just to do a little for loop. So we can say 50 times, which will be for 1 second. We'll go to the maximum position, and then 50 times we will go to the minimum position. Quick little format here, and this will toggle back and forth. We'll see that the servo is overshooting, which means that 1 second isn't quite enough time to do that either. But it's good enough for now. Now we don't really want to have to keep copying and pasting this servo code all over the place. We could move this to a function, but then we'd still have to be just calling this function. So a more interesting idea might be to actually use Embassy's tasks, where we can spawn a background task, which is similar to a thread, but it might not actually be running on the thread. It might just be using the asynchronous executor. So we do that by creating a new function. We call it an Embassy executor task. Servo control, and we're going to give it an output. Now here we can use P. We cannot use generics in a task at the moment, but I believe we can use an anypin. And then we will give it a control. Now here I want to use an atomic. Well, let's try it real quick. So in the servo control task, we'll create a ticker. We'll get our loop. And then we will read load. We're going to use ordering. We'll use relaxed because we're not synchronizing on any other variables. in this case, we're getting a control value, which is a U16. So we'll do that as F32 divided by U16 max as F32. All right, we need a lifetime parameter. The only one we're allowed to use is static. And this needs to be mutable. All right, so we have a little task here. Now, down here we can start a task. We've been given this spawner in main. So we need to spawn. We're going to call servo control. We'll give it the servo pin. And we'll give it control. Or let's create one. We'll go click. So 0. I think we need to give this a static reference. And we can degrade it down to an any pin. If we want an atomic that lives forever, we'll just create it forever. Okay, now we have a similar thing here, where now we want to set the servo control to need to give it an ordering, which will be relaxed again because we're not synchronizing on any other variables. And now all we need to do is wait. Wait for 1 second. We'll wait for 1 second again. Now what have we gained here? We've moved the servo control 50 Hertz loop to an external task. So that now our main loop can be free to do whatever it wants to, only sending servo control commands every so often. Let's see if this runs. Let's give that a little bit longer since the servo doesn't seem to be able to settle in the right position yet. Well, obviously the servo is not behaving as expected here. Now, the nice thing about this microcontroller is that it has built-in timers, which don't have to rely on the CPU working exactly as expected. So we can offload this control loop onto a hardware timer. Now the way that this works with the STM32, we're going to use the simple PWM driver. Now here, we need to give it a timer. We'll get that from the peripherals. TIM1 should be okay. Now we're going to give it 4 channels. We only need 1 channel. So we'll start by doing sum p.pb0, none, none, none. And then we'll do a frequency, hertz, 50 hertz, and counting mode, which we will use the edge aligned up. Now we're getting an error here because I did not pick the right channel. All right, let me show you where you can go to actually find the solution here. You open the documentation, you go to PB0, you can find that we can use timer 3 with PB0 and channel 3. All right, we need to create the PWM pin first. Set this as a push-pull. We do not want open drain. Now PWM pin should work fine. We don't need this anymore. We are not spawning another loop. We'll get rid of that since the hardware timer is now taking care of it. We're not using the atomic anymore. Now we need to enable the PWM. We'll need to enable the PWM, and now we're going to set the duty cycle of channel 3 . We need the max duty cycle, because essentially what the PWM does here is it has a number internally and it counts from 0 to the max duty, or max duty cycle. When it hits that max duty cycle, it resets down to 0. There is another register called the duty, which we're setting down here. And what it does is anytime it's less than that duty cycle, the pin is high. Anytime it's greater than that duty cycle, then the pin will be low. All right, so we know that the max duty cycle is the number, and the max duration is how long that actually compares to. So what we're going to do is use our servo on time function from before. We'll give it a 0.0 to start with. That's going to give us an on duration. Now we need to convert that. Convert everything to floats, and then once we've done doing the conversion, we'll convert it back to the EU16 that it wants. Let's move that to a function. And there we go. And we'll do it down here. I'll set it to 1, so now it'll toggle back and forth. if I name my variables correct. Alright, it appears that this servo wants to be told a little bit more frequently than 50 times a second. I have it set now to 120 times per second, and it seems quite a bit happier about that. Looks like it works even 100 times per second. Let's try 80 times per second. Times per second. And back down to 50 times per second. Wow. Seems that this servo actually really cares a lot about how frequently we tell it. If we tell it very frequently, it seems that it checks every time we tell it. It doesn't have an internal loop, so if we want it to be more accurate, we need to tell it very frequently how long to run for. These servos can be very kind of tricky to control, so you might need to be able to play around with these parameters to see how everything works. So now that we see that these PWM controllers with the built-in timers are much more accurate, where can we go from here? Well, here it really depends on what you want to do. What are you going to connect the servo to? Are you connecting it to the eyelids of a robotic eye or the legs of an animal? Here you're going to do your own thing to figure out how this all works. Here you can use these tools in your own projects to move servos. Thanks for watching. Did this video meet your needs? Let me know what you want to see next. Thanks.